Hi everyone, just a quick little tutorial today that will show you how to create this kind of effect. So it's just putting a load of spheres into a cylinder and then using a motor to kind of power that around so that all of these things kind of get caught up and pushed to the edges and spin around like so. Okay, it's just a technique thing really. So let's get ourselves some spheres. I'm going to create a mesh network. I'm going to make sure it's an instancer just because it'll be faster. Let's make a grid and let's have maybe this many. I'll show the sphere, bring it over here, and then I will just add a material to it so that we can just add a ramp just so we can see the rotation really. Nope, that way. Just I want none, and I do want to do that. Okay. Let's do this. That red hurts my eyes, so let's just take a little bit of the sting out of it. And same thing for the blue. Let's just do a similar thing. Okay, so here are our spheres. Brilliant. Oh, they're intersecting. That's not great for dynamics. Let's just fix that. Let's go. Let's do that. Okay, so okay. Now I'll just hide this. Just create a cylinder. Rather large, rotate it sideways. I'm going to turn on X-ray so that we can see inside it. Just rotate that 90. I'm going to make it have a lot more subdivisions in the axis because the smoother the surface is, the less jumpy the rotation will be. If this is kind of really faceted like this, the points will kind of hit the sides and bounce off, and we don't really want that. So more size means smoother. And it won't really affect the sim speed. So, okay, so in the Smash network, let's add dynamics to this, like so. And then if I just hit play, all the spheres fall to the ground, and there you go. And then let's grab this cylinder and then create a mesh network. Again, it's made 10. I only want 1. So, X-ray doesn't work with the instancer. Okay, so here's our cylinder, and then on this I'm going to add dynamics as well. And if I just press play, everything goes kaflooey, and that's because the spheres are being pushed to the outside of the cylinder, because the cylinder obviously doesn't exactly have a hole in it. However, we can make it two-sided by setting the collision shape to mesh here. So if I just push play now, then they're stuck inside. You see what's going on there? Okay, right, rewind. Cylinder. I'm going to increase the mass in the cylinder to something like 50. You see it was a bit jittery before where it fell. Now it will be a lot less jittery because its mass is heavier than the spheres, all of them put together in fact. And I will rename the network, so we'll call this one, sphere network, and we'll call this one drum network. Okay, so on the drum network here, I don't want it to fall to the ground anymore, so I'm going to add a constraint. So just add a constraint. I will change the type to, custom. I'm going to say connect to offset point, which will connect it to itself actually. Okay, so if I just hit play now, see that all that happens is a little bit of rotation goes on. So just watch that again, so you can see there's a little bit of rotation happening. And that is because by default a custom constraint, if I look at the limits here, positions are fixed and the rotations are free. So I want this to spin in the z-axis, so I can go fixed in here and in here as well. Then when I press rewind and play, see there's just a little bit of rotation in that axis. I can then turn on a motor. So if I turn on a rotational motor and say put 100 in Z and maybe 20 in the target speed, you can see it turning around now. Okay, so let's just hide the drum network and then hit 6 so we get our materials back. Just see what's going on. So So it's rotating there. You see there's just a little bit of rotation here. So I want to increase the friction a little bit on the drum dynamics and on the spheres, just so they kind of catch a bit more. And then on the drum network, we can, oh, no, dynamics, on the constraint, I'm just going to increase the power of that. So just the maximum force, and then if I up the rotation speed, you see what we've got going on here. You can, if you want to, in fact, now can I use draw overrides? No, I can't. Oh well, I thought I was going to try and be able to see through this at the same time. So we can see how fast this is rotating like this. Anyway, so it's rotating very quickly. And you can animate the speed of this just by animating the target speed value. So we can animate this from, say, 0 to, let's say from 500, we can say put this up to 200, something like that. And then if I hit 6, so to begin with, not a lot happens. And then the drum is speeding up, you can see. And I could probably want to make this a little, probably want to make this go even faster than that. So frame 501, let's try this at 500 instead, just see if we can get that kind of the effect I had in the video I showed you earlier on, which is where they all kind of like spin around the edge. So okay, so probably a bit overkill there, but there you go. So that is the that's the effect. That's how I did it. It's pretty easy to set up, really. So the next thing we need to do is let's get a better version of this drum, in case, you know, just pretend we want to replace it with a better model. So let's just get the original cylinder, we'll duplicate it. I'm going to grab the vertices on the end and go select, convert selection to faces, delete that, select the object, and then extrude it out a little bit, like so. And then with that done, we'll say this is our better model. And we want to get this to inherit the rotations from that mesh network, even though it's not in the mesh network. So we bring up the drum network now. The way we would do this normally, by the way, is the breakout node. So there's a tutorial on that, but I'll just show you how to use that with dynamics. So if we go node editor, we can see that we have the drum network's dynamics. We've got this drum network waiter, and then that plugs into the solver, bullet solver. And the bullet solver then plugs into an instancer for the sphere network, and then one for the drum network. So if I open up these output points here, we've got 0 going to the sphere network and 1 going to the drum instancer. Okay, so that all said, we've got the drum network here. Let's add a breakout node. I wish they would stop regraphing. And the breakout node has been added to the waiter, which is kind of the normal behavior. However, we've got dynamics, and so we want the positions from the dynamics, not the positions from the waiter. So we just need to plug output points 1, which is the one that goes to the drum. We need to plug that. Oops. Hit 2 to show the inputs or connections. So we need to go from output points 1 into the input points here, and then what we can do is we can drag in our cylinder model, and we want to go rotate Z into rotate Z, like so, which is giving us a connection. And then I select this, you see that it is rotating, so it's going very, very quickly. So you can see it kind of starting, speeding up, and then optical illusion looks like it's going backwards. So that is basically it. So that's how you use the breakout and how you get this going. And ta-da! I hope someone finds that useful. Just a little trick using motors, breakout, all that kind of thing with the dynamics. And yeah, let me know what you make with it.